Okay, guys, let's go ahead and look at this side of your homework for tonight. So looking at the side that's rational and irrational number relationships. So what I'm going to do is I'm going to start out, I'm going to work through A so that you can see how I do it. I'm going to look at a couple of B to help you make sure that you understand what's going on, and you'll finish B, and then C, you'll end up finishing totally on your own. So if I look at A, we're doing the square root of 25. So remember that with square root, I want a number that I can multiply times itself and end up with 25. So if I'm thinking about that, I know that 5 times 5 is going to equal 25. So that means the square root of 25 is 5. Number 2, square root of 4/16. So we have to do the square root of the numerator. So square root of 4. 2 times 2 gives me 4. So that tells me that our numerator is going to be 2. Our denominator, I need to do the square root of the denominator. And so the square root of 16, that gives me 4, because 4 times 4 gives me 16. Now when I look at that, that actually will reduce. And so 2/4, when I reduce that, that will give me 1/2. Number 3, cube root of 125. So I want a number that when I multiply it by itself 3 times, that I end up with 125. So when I go 5 times 5 times 5, that equals 125. And so that lets me know that my answer is 5. Number 4, cube root of 8. So a number times itself 3 times to get 8. 2 times 2 times 2 gives me 8. So the cube root of 8 is 2. Okay, looking at B briefly. Okay, you have perfect squares, square root of 9, square root of 81. Cube root of 1 is a perfect square. Remember on this fourth one here that the square root, the cube root of 27 over 64, that you're going to take the cube root of the numerator, okay, so cube root of 27, and that's going to tell you what goes there. And then when you do the cube root of 64, that's going to tell you what goes there. Okay, so go ahead and finish up B and C. Now, let's look at the bottom, the middle part here with 5 through 10. You want to approximate the values. Now, if you notice over here on the side, I've created a number line to help us see where these square roots would fit in, because these are not perfect squares. You cannot memorize these. They will come out to a nasty long decimal that is not terminating. So let's look. We're going to go through a couple of them, and a couple of them just kind of get you started. So looking at number 5, we want to know the square root of 10. Well, I know the square root of 10, it has to be, square root of 10 is bigger than the square root of 9, but it's smaller than the square root of 16. So that means it has to come in here in between that 3 and that 4. So I know it is between 4 and 3. Now, just to kind of add a little bit extra to it, which one is it closer to? Square root of 10 is just barely bigger than square root of 9. So that means it's actually going to be closer to the 3. Okay? Number 6, square root of 74. So with square root of 74, I can see it's bigger than square root of 64, but it's going to be smaller than square root of 81. So that means it's going to end up coming right in here on your number line. So you're going to fill in number 6 for what it is between. And then I want you to go ahead and circle which one is it closer to. Number 7 on your own, finishing up number 7. Let's look at number 8. Number 8, square root of 17. Square root of 17 is just bigger than square root of 16, and it's smaller than square root of 25. Now when I look at it, square root of 17, it's barely bigger than square root of 16. So I know square root of 17 is between 4 and 5. Now, which one is it closer to? I see that it is really close to that 4, so it is closer to 4. Number 9, square root of 2. So, looking at our number line, square root of 2. Square root of 2 is bigger than square root of 1, but it is smaller than square root of 4. So that square root of 2 is going to end up coming in right here. And so that'll let you know what numbers it's between. And then I want you to go ahead and try to circle the number that it is closest to. And then go ahead and finish up number 10. Okay, so let's go ahead and look at the bottom section of this paper. We're going to do it like we did before. I'm going to look at column A, get you started on column B, and then column C you'll be totally on your own. Now before we start looking at them, as a reminder, remember that we have our inverse operations. Add and subtract are inverse. Okay, subtract undoes addition, addition undoes subtraction. Multiplication and division are inverse operations. Multiplication undoes division, division undoes multiplication. Squaring and square root. If squaring is the inverse of square root is the inverse of squaring. Okay, then we have cubing and cube root. Cubing is the inverse of cube root, and cube root is the inverse of cubing. So that'll help you out with these equations. So let's look at the column A. X squared. We need to do the inverse to get x by itself. That means the opposite. The opposite of squaring is square root. So I'm going to do the square root of both sides. Square root of x squared gives me x. Square root of 64, that's going to give me 8. Now, we have to be careful right here, because remember when we're solving these equations, if we are doing square root, that our answer can be positive and it can also be negative, because a positive 8 times a positive 8 equals 64. A negative 8 times negative 8 also equals 64. So we can have positive or negative, so we have to make sure to include both of those signs. Moving down to 12 on the A side. Cube root of x equals 6. So we've got to do the opposite. The opposite of cube root is cubing. So we're going to take this side, we're going to cube it. We're going to take this side, we're going to cube it. Okay? Cube root of x cubed is going to leave us with x. Then we will look at 6 cubed. 6 cubed gives us 216. With cubing, however, we only have one answer. So x equals 216. Okay, looking at B. Okay, getting you started. Square root of x. The inverse of that is squaring. So that means, remember, we have to do, if we do it to one side, we have to do it to the other. So we're squaring. That's going to leave you with x. And when you do 9 squared, you will find out what x equals. Looking at B, x squared. The inverse is square root. So square root of x squared, square root of 121. Square root of x squared is going to give you x. Square root of 121 is going to give you your answer. And then go ahead and finish up with C. Okay, let's go ahead and look at the back side, the other side of this paper. So, going through number 1, cube root of 125. So you want to know what number times itself 3 times is going to equal 125. So when you do that, cube root of 125, 5 times 5 times 5 equals 125. So that means the cube root of 125 is 5. Number 2, just getting you started. Think about it. Something times something times something equals 343. And that's going to tell you your answer. Whatever it is that goes in there, that'll tell you the cube root. Okay, and then go ahead and finish up with number 3 and number 4. Looking at the bottom section, solving the equation. Number 5. Okay, just like we looked at on the other side, we need to do our inverse operation. The opposite, the inverse of b to the third power, or b cubed, is cube root. So I want to do the cube root of both sides. Now, cube root of b cubed is going to leave me with B. And then when I do the cube root of 1,728, that leaves me with 12. Okay? Number 6, you're going to do the cube root again, okay? Because we have to do the inverse operation. So, cube root of 8 cubed. Same thing here. Cube root of 8 over 216. You're going to do cube root of 8, cube root of 216, and that's going to let you know what your fraction is. Now, remember, if you can simplify that fraction, you will need to go ahead and reduce it to its lowest terms. Number 7, volume of a cube, and it tells you that volume. Okay, when we think volume of a cube, remember that that is a three-dimensional shape, if I can get that drawn here. Okay, so for volume, we have to know the side, the side, the side. And so with a cube, volume equals S times S times S, or volume equals S cubed. Now, they tell us the volume, 3,375 equals S cubed. So we've got to do the inverse operation. Cube root of S cubed. Cube root of 3,375. When I do that cube root, that's going to give me 15 equals S. Now, going back, looking at my unit. Inches cubed is for volume, but for the length of the side, or the height, that's going to be 15 inches. Number 8, getting you started. Volume equals S cubed. Here it's telling us the volume is 216, and that equals S cubed. So you've got to do the inverse operation. So you've got to do the cube root and the cube root, and that's going to let you know what the side is, to know what the length of that cube is. So you're going to go ahead and finish that up. Don't forget to put your unit on your side length.